managing shards, maintenance windows, over-provisioning, elastic cache bills. I know, it's a spooky season and you're already shaking. It's time for caching to be simpler. Memento serverless cache lets you forget the backend to focus on good code and great user experiences. With true auto-scaling and a pay-per-use pricing model, it makes caching easy. No matter your cloud provider, get going for free at gomemento.co/morning. That's go, momento.co/morning. What is Kubernetes? Well, let's start by pronouncing it. You could go with Kubernetes, 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 Kates, K8S, Kubernetes, Kubernets, Queepier-Neds, Kubernandos, Kuberkitties, Kubernetes, Kubernoots, Kubernetes, Klubernetics, Klubernetes, or Cumberbatch. I'm just going to call it Kubernetes from the original Greek name of the god of spending money on cloud services. Now, according to my notes, Kubernetes is an over-engineered solution that's largely in search of problems that are best solved via other methods. Oh, sorry, I'm supposed to be taking this seriously. Okay, Kubernetes is a Russian psyop. No, sorry, wrong card there. Great. Kubernetes is so easy to use that a company devoted solely to troubleshooting issues with it has raised $67 million. That one's actually true, but we'll try it one more time here. Because in all seriousness, Kubernetes is an open source system for managing containerized applications in production environments. And I'm using it for the first time as I go about deploying a production service. But before I get too far into Kubernetes, I want to review how we got here, what problems it solves, and what kinds of problems it's created. To begin, we have to go back in time. Pull out your boogie shoes because we are discoing back to the 70s. It was then that IBM introduced logical partitions on mainframes. LPARs divided mainframes into subsets that each ran their own instance of the operating system and got a fraction of the mainframe's resources. In other words, containers. IBM stayed in the 1970s, at least culturally speaking, but its concept didn't. Virtual machines, BSD jails, Linux cheroots, and other similar technologies proliferated. Pull on your Uggs because we're fast forwarding to 2012. In those days, developers spent way too much time saying things like, well, it works on my machine, and then grumpy ops people like me snap back with, well then, Skippy, back up your email because your laptop's going to production. I wish I were kidding when I say that one of the biggest problems in tech was how to make your MacBook Pro look like a Linux server. They were simpler times. It was then that a company called .cloud released something called Docker. Docker created an underrated, streamlined user experience that just got out of the developer's way. When an application looked like it was in a fit state to ship, developers could hand off that container to their ops folks, and ops could deploy it to production. The application would immutably be the same version of code along with all of its runtime dependencies, all packaged up in the form of a container. In short, Docker fixed a whole mess of problems from the developer's perspective. It also opened up a whole pile of new problems for the ops folks who ran containerized applications in production. Among the many products and projects to create an ops solution was a contender from Google. Google had already been using their internal cluster manager called Borg. It's as if Borg's engineers asked themselves, if we could make Borg all over again without relying on internal Google infrastructure things, how would we do it? And the answer was Kubernetes. The name was really a nod to the ancient Greek for helmsman, if the nerds in Google's marketing department who named it are to be believed. In any case, Kubernetes steered its way into the lead. By the end of 2017, Kubernetes was so predominant that its competitors embraced it natively. VMware adopted it over its own Cloud Foundry. Docker stopped pushing Docker Swarm as the better solution. Mesosphere pivoted so hard from Mesos to Kubernetes that it renamed the company to D2IQ, presumably after its favorite droid from Star Wars. Snark aside, Kubernetes provides some very real value to its adopters. If a hardware node crashes or has a failing disk array, Kubernetes can seamlessly route around it. If a container stops responding, Kubernetes can replace it automatically. Kubernetes can effectively play a game of Tetris to get various workloads packed into fewer servers so their resources don't go unused, as was demonstrated by Kelsey Hightower in several keynotes where he literally played a game of Tetris to achieve the same thing. And of course, Kubernetes is now the lingua franca of multi-cloud. Every current and aspiring cloud provider today supports Kubernetes on its platform, but Kubernetes has its drawbacks and then some.
Forget everything you know about SSH and try Tailscale. Imagine if you didn't need to manage PKI or rotate SSH keys every time someone leaves. That'd be pretty sweet, wouldn't it? With Tailscale SSH, you can do exactly that. Tailscale gives each server and user device a node key to connect to its VPN, and it uses the same node key to authorize and authenticate SSH. Basically, you're SSHing the same way you manage access to your app. What's the benefit here? Built-in key rotation, permissions as code, connectivity between any two devices, reduced latency, and there's a lot more, but there's a time limit here. You can also ask users to re-authenticate for that extra bit of security. Sounds expensive? Nope, I wish it were. Tailscale is completely free for personal use on up to 20 devices. To learn more, visit snark.cloud/tailscale. Again, that's snark.cloud/tailscale.
The first and most obvious challenge is the borderline overwhelming complexity. Once you have an application running in Kubernetes, you need to dramatically uplift your telemetry story. The old days of log into the Linux box and check what it's doing don't work when the container stopped existing 20 minutes before you knew there was a problem. The applications running within a cluster need to be able to find one another. The CI/CD process of getting code changes from developer laptops into production has gotten far more complex. The cascade failure model that takes down entire fleets of servers is now a lot more damaging than it used to be, and countless more problems exist to ensnare the unwary. So many of these infrastructure issues are precisely the kinds of things that I pay a cloud provider like AWS or Google Cloud to handle for me. Most overwhelmingly, it seems that Kubernetes is catnip for engineers who thrive on being clever, and by clever, I mean unnecessarily complex. When something like Kubernetes breaks, it can be extremely tricky to find out exactly where to go to fix it. That leaves us in the present day where I still have no clue how to navigate the murky waters of Kubernetes. Helmsman? It's more like hellish, man. Am I right? Whatever it is, I just know that I've got zero problems admitting that I'm in over my head with Kubernetes and shrieking for help. Stay tuned, there's much more to come.
This has been a Humble Pod production. Stay humble.